This video is on polygons and quadrilaterals. So what I want to show you here is how you can recognize a polygon. If you look at these four figures here, we have a few of these that are going to be polygons. Let's look at ABC. What I notice on ABC is that all the sides are straight and they are all connected. I see 1, 2, 3 sides. ABC is a polygon. Then you look at FGHIDE. And when I see this, again, I actually see a bunch of straight sides and they are all connected. So number 2 is also a polygon. Let's look at number 3. It says JKLM. I have 3 straight sides, but this one is not. This is not a polygon. On number 4, let's look at NORQ. That is not where the lines are connected. If it was, it would look more like this, NORQ, but these lines are missing. You cannot go on a polygon where your NO and then notice that R and O are not connected. We can't work with that, so that is not a polygon. So let's look at what the definition of a polygon is. A polygon is a closed figure that has at least 3 straight sides. So the sides have to be straight and the figure needs to be closed. Remember, when you name a polygon, you can select any vertex to start with, but then you're going to proceed clockwise or counterclockwise around. For example, let me draw a rectangle here, and I'm going to go ahead and do this. You can pick any vertex you want, so I'm going to pick B. So I can call this rectangle B, and then we're going to go clockwise, CDA, so BCDA. Or I could go backwards here, counterclockwise, BADC, BADC. What I cannot do is I cannot jump a vertex here or go across. That is not appropriate in naming a polygon. A polygon that is convex means that if you look at all the interior angles, they all have angles that are smaller than 180 degrees. So you look here, this is a triangle, and of course these are all going to be smaller than 180 degrees because of the triangle sum theorem. But if you look at this one here, and you look at this angle on the inside, 180 degrees would be from here to here. This actually goes beyond 180 degrees, so the measure of this angle right here exceeds 180 degrees. Therefore, this is going to be what we call a not convex polygon. So this one is convex, this one is not convex. When you look at diagonals of a polygon, diagonals are going to be any segment that connects 2 non-consecutive, meaning non-adjacent vertices of the polygon. See, these 2 are called adjacent vertices because they're side by side. But if we go with this one and this one, they're not connected, they are not adjacent. So that is a diagonal here, as well as this right here is going to be considered a diagonal. If we look at this pentagon, we can count how many diagonals we have. We have 1, 2, 3, 4, and 5. And there's no other way that I can connect any of these vertices without connecting 2 adjacent. So this has a total of 5 diagonals in this pentagon. So when we get into types of polygons, they have different names. When we deal with this type here, we would say a 3-sided figure is called a triangle. A 4-sided figure is called a rectangle. A 5-sided figure is called a pentagon. A 6-sided figure is called a hexagon. A 7-sided figure is called a septagon. An 8-sided figure is called an octagon. A 9-sided figure is called a nonagon. And a 10-sided figure is called a decagon. The only other one that is typical that we know, you'll see probably in vocabulary, is the 12-sided, which is going to be the dodecagon. I'm going to have you look that up on spelling it. I definitely misspelled that. Dodecagon. All right, so let's move into what we call quadrilaterals then. When you go through this, you might want to push pause on the video because these are the definitions. I'm not really going to add more to it. But in our quadrilateral here, it is a 4-sided figure. A parallelogram is a quadrilateral, meaning a four-sided figure, in which both pairs of opposite sides are parallel. So you'll notice here these two parallel marks, they match, so these sides are parallel as well as these. Both pairs of opposite sides are parallel. Looking at a rectangle, this is considered to be a parallelogram, so remember a parallelogram is a quadrilateral, a four-sided figure. So it's a parallelogram in which at least one angle is a right angle. So at least one right angle. That's all you need to look for. If you know that this is a right angle, eventually I'll show you how to prove that the rest of these angles are definitely right angles. A rhombus. A rhombus is a parallelogram, so opposite sides are parallel, at which two consecutive sides, meaning two sides that are touching or adjacent, are congruent. So if you look, we have the congruence mark here and here. So two consecutive sides are congruent. A square is a parallelogram that is both a rectangle, meaning it has one right angle or more, and a rhombus. It has two consecutive sides that are congruent. A kite is a quadrilateral in which two disjoint pairs of consecutive sides are congruent. So these two disjoint pairs are going to be congruent as well as these two. It's not a parallelogram, it's a quadrilateral, a four-sided figure. And so basically we have two sets of consecutive sides that are congruent. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So we have here, it has one pair of parallel sides. And finally, an isosceles trapezoid is a trapezoid in which its non-parallel sides, so these are the two sides that are parallel, so we're talking about these non-parallel sides, called the legs, are congruent. So that is your quick tutorial on quadrilaterals and polygons.